Welcome everybody to our webinar. My name's Stuart Farr, President of Deltix. Today, it'll be myself and my colleague Ilya Gorelik, Ilya, CEO and founder of Deltix up in Boston, and we'll be taking you through. First things first, we'll just put up the agenda there. I'm not going to run through the items on there, they're self-explanatory. Now, just to move on in terms of Deltix, some of you know us, so this is going to be fairly brief, but we are a software company and all we do is provide software and solutions for quantitative research, quantitative trading strategies, algo execution, market making, and what's sometimes now called intelligent trading. That's our singular focus. We have been operating nearly 12 years now, and most importantly, we have over 70 employees, the vast majority of whom are computer scientists or mathematicians, many with advanced degrees. So we're very much a tech shop, very much content-based, and that's the way we like it. The main product set that we've had over the years and still have, and is our main product set, is time-based Quant Server and Quant Office, and between them, they have won over 12 awards over the last few years, which we're very proud of. Those products have been deployed at over 175 clients. We currently have more than 60 clients. And the number at the end there, very importantly, this technology stack has over 500 years of investment in it. So that's really the backdrop. That's where we come from. I'm going to hand it over now to Ilya, who will continue the story and how we transition into QuantHub.
Thank you, Stuart. So our story and our transition to QuantHub started as expected from us solving difficult problems related to development and deployment of quantitative strategies. So this slide represents the typical workflow that everybody, no matter what kind of strategy you work on, whether this could be alpha generation strategy or market making or algo execution, they all go through these 6 kind of standard steps, from data acquisition and preparation to development of ideas, codifying them, programming them, backtesting, simulating, and running in production. And we've been working on this workflow for the last 12 years, and we put together the 3 pillars of our technology, specifically time-based, which is our messaging middleware and a database for storing time series data, Quant Office, which is our development studio, and Quant Server to run everything live. And we learned tons of lessons during this journey. Specifically, we kind of expanded this universe to solving 3 problems: aggregate, analyze, act. So our technology today is closely integrated and runs on the private clouds or in desktops or laptops, but typically in the clouds. And what we've learned during these years of working with our more than 170 clients, we're going to present right now in our QuantHub technology. So main thing about QuantHub, it runs on a cloud. And 3 key themes in this slide are kind of obvious. First of all, ability to execute massive amounts of experiments. And by massive, I mean millions, at least hundreds of thousands. So any user of our software in the past, or at least a lot of them, at one point was working on optimization, some on machine learning, some on pattern recognition. All these tasks require repetitive execution of the same typical, what we call backtest run, which runs on many years of historical market data, on many tickers, and of course it's time consuming, CPU consuming, and so running massive amount of experiments can be accomplished only if it's deployed on a cloud in parallel type of calculation, distributed computing kind of mode. We build a lot of technology for that in our core system, and now it's all in the cloud. The second theme, which is really important, is collaboration, knowledge transfer, and publishing. A lot of times we were presented with the need to share the strategies, share ideas with other users, and definitely in the desktop environment, even in the private cloud environment, it's very difficult. So we're trying to address this need, and I'll show today how it's done, especially the new idea of active widgets, where every published application would be presented with dynamic controls which can be applied and tried for real by users. And finally, everything in Deltix is based on open intelligence concept and hence open architecture. Here we're trying to respond to the following issue. As you all know, the new open source, especially big data kind of products, they are exploding and we can't ignore their presence. And as such, we build the facility for what we call plug and play orchestration of various software systems. So even systems like Spark and Jupyter and machine learning application, they will be part of QuantHub. And that's very exciting. So to accomplish these 3 goals, we build system on the cloud And I'd like to quickly give you an overview of our system, starting from, obviously, the physical cloud infrastructure consists of computing and data management nodes. So we're deploying it in different clouds. It could be right now, our current demo would run in Microsoft Azure, and every node will consist of Deltix libraries and instance of Timebase. And from software perspective, we have 6 main engines. The first one, of course, is data management engine. So everything in any quantitative research starts from data. And data management engine is a core part of our technology. It's based on time-based technology, and in a few minutes, I'll show you how it works. But that's engine number 1. Next one is definitely distributed computing task management engine, which deploys tasks on different nodes, make sure that they're all properly managed, deals with exceptions, deals with failures, deals with all the orchestration of different calculational agents. Research workflow and result analysis engine is the third one. And as I mentioned, if you run massive amount of experiments, clearly the task of analyzing results of them, if you're dealing with millions of them, just by itself, it's a pretty difficult thing. 3 other engines, presentation, visualization, collaboration, and administration, they're kind of self-explanatory. So let's look at QuantHub architecture. This actually may be a busy slide, but I'll start telling my story from top right corner. So everything starts from data. And so we have a special node for data management where using time-based APIs, we deploy data to master node, which contains master time-base. So master time-base is the core image, which contains all data which would be required by all computing nodes. And so the master node is scalable, redundant facility for storing pretty much hundreds of terabytes of data. The next will go clockwise, distributed computing task manager. As I mentioned, running massive amount of experiments, you need to manage it. And for current instance of QuantHub, we're using Apache Mesos technology. So we're using Mesos to manage different tasks. And as you can see on the right, computing node would be just simply populated with computing task manager Mesos agent. And then, as I saw it, time-based and strategy execution will be done on the computing nodes. Research workflow and analysis engine, it's a bottom right corner. So like I described it, supposed to deal with all the experiments. And for just the ad hoc analytic, we're using ClickHouse technology. And this ClickHouse technology definitely works well for us. Then publishing collaboration engine allows strategies to be communicated to anybody. The typical quants who use the system today, they build their strategies in their desktop environments, and we support pretty much any language, including even the recent Scala kind of plugins. So the strategy repository. And finally, I'd like to talk about this use case where QuantHub can be used not only as a cloud-based backtesting machine for strategy deployed on the cloud, but you can also run them locally on your computer. So you can connect to QuantHub data management bus and receive data on demand. And so we can analyze data which is already produced by QuantHub backtesters, or we can take raw data through pretty much extremely well-defined REST and REST APIs. So with that, I would like to show you a quick introduction of QuantHub. Let's go to my browser. And on this page, we see the entrance page to QuantHub. It contains of all my recent activities, so we can see different strategies, what I did with them. Contains my recent publications. I'm running currently instance of my cloud, which I named IG. It contains of 2 nodes, reasonably good computers. And the core theme of QuantHub is running massive amount of experiments and running big amounts of strategies. So if we go through menu at the top, they all organize around workflow. First of all, research. We got strategies, which is the core concept. Each strategy contains of experiment sets, which are natural since we're running a lot of them, and then experiments and documents. Then we go to publications, favorites, libraries, and tools. Even the first version of QuantHub supports Jupyter and Spark, and later we can talk about it. So my first demo would be, we go to strategy panel, and I look at all my strategies. And what can we do with every strategy? Of course, we can first add strategy. You can put pretty much add any software which is compliant with QuantOffice standards and APIs. However, we also did a very important development. Now I jumped to Azure, master node, and there's a master instance of a QuantOffice where we added new command called supporting submission of strategies which are developed in QuantOffice for backtesting and execution on the cloud. So one of strategies I already created, it's called speed benchmarks. This will be our first strategy. When I click on it, we came to what I call strategy homepage. I'd like to walk you through what it contains. First of all, on the left, we look at all experiments which currently already associated with the strategy. I can definitely collapse, expand. Very new concept in every strategy is a concept document. We'll work with it because it's going to be used as the publishing kind of agent. Every document here can be dynamically edited, and we'll do these edits in a few minutes. We're using this markup language and technology for Markdown, which is used in a lot of open source communication platforms. So with that, I'd like to quickly run to this test called run demo. Let's click on this command, and I will push this button. I'll just run it again. So this is a very important part of a QuantHub. It's an experiment execution workflow. It has 5 panels, the input parameters, the basic parameters which we will be using for defining strategies, output, and execution. This particular strategy will be used by us to scan around 100 million messages, around 9 future contracts, and I'd like to show this page. We're going to deploy it on my cloud, where basically I connected to IG, and I'm going to break it by instrument. So we're going to have 9 runners executing this strategy. With that, let me click command run. I'll give it a name. I'm going to run every demo today, naming them run webinar. It's all live, so we never know what happens. When I click on this experiment, the strategy has been deployed, 9 cores been activated, and now we'll see the statistic. So literally 100 million messages will be processed by us. This is the speed. On average, we're processing around 300,000-400,000 messages per core. And currently, I already processed 50 million messages. And in a few seconds, hopefully, this experiment is supposed to take no more than a minute. We'll be done with the first run, and we'll look at results of this run. As you can see, as we finish certain symbols processing, they become kind of to pause, and the last one is still running, period. We finished. With that, I click on command run, and let me refresh my screen. And I'd like to click on custom reports. So this custom report panel basically walks us through statistics. So we got each symbol. For each symbol, we found what was our approximate processing speed and how many messages we processed for this symbol. We were streaming all messages to all nodes, and we're filtering per symbol. And right now, I'd like to show you some interesting observations. So we got level 2 snapshots, trades, BBO in our stream. And if I go to bar chart component, we will see that, let's say I'm interested to see how many trades my system contained per instrument. So I click on this command, and we can see immediately distribution of trades. For example, crude oil, and next to it, E-mini had pretty much a lot of trades. If I do right now the same statistics, but instead of trades, look at best bid offer messages, which we also calculated, we're seeing that the diagram is pretty much almost identical. So let me run quickly scatter plot and see a relationship between how many, on the axis, I will look at best bid offer messages, and on the y-axis, I'll look at trades. And as we expected, there's regression. However, in this particular case, we found that there's 2 instruments which have pretty much exactly the same amount of best bid offer messages, but very different amount of trades. Who they are? I click on this cell, on this dot, and immediately I see that this is my treasury node contract, which had around 50,000 trades with around 1 million best bid offer messages. And this one is a crude oil, which definitely has more trades, more activities, but still, it's kind of interesting observation. With that, I would like to kind of complete my intro presentation and pass conversation back to Stuart.
Thanks, Ilya. So the next item on our agenda is to have another use case, and this is where we use QuantHub for alpha research. Now, the subject of this research is a study we did actually 18 months ago using some data from Wall Street Horizons. And what we did a couple of months ago, we updated that study with more recent information, and that's what we're going to show you now. But before doing that, I just want to give you a brief background to that study. So when Ilya shows you it, it'll have the context. The actual full study you can download from our blog. We'll send that to you in the presentation when you get it. So you don't need to write this down. It's fully referenced in the blog. But just to give you a brief description of what's going on here, the core data set is Wall Street Horizon's earnings data. Now, everybody uses earnings data as they have for a long time. The twist here is that this particular data set has the announcement dates and particularly changes in the announcement dates. And it turns out that companies, when they make an announcement of their future announcement dates, sometimes and actually quite often change that date. So they may bring that date forward, they may push that announcement date back. So what we did is we postulated that there may be a reason for that. And essentially the strategy we came up with looks at when they bring the announcement date forward, and we'll take a long position in that stock. When they push the earnings date back, we will take a short position in that stock. And we take those positions on the market close the day of the announcement. And then on the market open the next day, we close the position. So it's a very short holding period. It's less than a day, in other words. And that's essentially the nature of the strategy. It's as simple as that. And Ilya will show you that now, and then how we can change some of the parameters. So Ilya, if you could just continue that story.
Thank you, Stuart. Definitely. So as you can already anticipate, I'm going to have a strategy, Wall Street Horizon, right at the top of my page. And I go to my homepage about Wall Street Horizon strategy. Again, the same philosophy, experiments, and a document. However, this document, as you saw in my previous kind of literally a few seconds ago, this is what we currently have on our website. You can just simply download this document, and that's all you can do in this particular context. So we wanted to change it. First of all, this document is completely editable, and it's completely kind of collaboratively enabled, and I will talk later about it. But first thing I'd like to do with this particular strategy is to challenge one assumption, actually two assumptions. So current strategy, Stuart said, takes a holding period for 18 hours. And what if we hold positions longer? And also, what if we choose some signals which may or may not be the best fit for the money making? So for that, I built a dashboard, which you can see right now. It's actually written in Python, and it's deployed on a separate node. One use case which I described before, I'm becoming an agent of QuantHub. So I'm connected to QuantHub to read data from the master time base, actually through APIs. And in this particular dashboard, I'm going to walk you through one very useful example. So we modified Wall Street Horizon strategy. Instead of just doing backtest, we writing signals to a stream. And so this particular dashboard, which we built to analyze signals, compares what happened, first of all, for different industries. So we got different sectors, materials or healthcare. But the most importantly, we'll look at two charts at the top. This is the scatter plot, which compares historical, actually forward returns, 1 day return versus 2 days returns, or for example, 1 day return or 4 day return versus 5 day returns. You can see sometimes they have regressions, but most importantly, for my demonstration in this chart, here we put a histogram of forward returns. So we calculated a 1 day forward return, 2 day forward return, and 3 day forward return, and we can see that the signals which Wall Street Horizon strategy generates definitely have a positive attitude, I would call it this way. You see the distribution is definitely shifted towards the positive returns, which is good. And it's actually, this pattern would be repetitive for different industries, which is also cool. I'm choosing sectors, and we can see that this pattern kind of holds. And now let's compare. I'll choose it for all. It's going to be around 7,000 signals. Let's compare this return, which I overlaid with 2 day returns. And bingo, we're seeing that it's interesting that if I hold position for 1 day, it's probably going to be better result than I hold it for 2 days. So what happens if I hold it for 3 days? Immediately, we will see the similar assumption. I magnify this page. And so this is the kind of example of a Python-driven analyzer, which shows us some hypothesis. So I'd like to take this hypothesis to fruition, and I go to QuantHub, and I run this study. So we already built this study. Obviously, I don't want to run it live. don't build the whole setup live. I'm just going to repeat it. I'm going to click on Command Run again and walk you through the thought process. So in this thought process, again, let's look at the parameters. We have 451 instruments in our universe. And if I click on parameters, especially input parameters, now I'd like to talk to you about new concept. So we're going to build massive amount of experiments. And right now I'm taking two parameters to construct my experiment. First is how many days I'm going to hold the position. So I build the interval from 1 to 15, and we can see this list from 16 different experiments based upon how many days we're going to hold the position. And the second parameter, I'm going to build two buckets. In one, I'm going to put all signals which have obviously significance, which greater than 0. I'm going to measure signals based upon what was the actual amount of days which Wall Street Horizon publishes as adjustment. So whether we move more than 5 days from original date or whether we move more than 2 days. So we're going to rank all the signals based upon this delta, how many days we offset original date. And we have two buckets. 0, which is all signals. It will be obviously a superset over 5. So all signals we have greater than 5 days of shift comparing to all signals. And with that, let me click on Finish command, and I'll run this webinar by saying Run Webinar. So we're going to deploy these 32 experiments on 24 cores, and let's see how long it's going to take us. Again, everything is live here, and we'll look at the running strategy. We're utilizing 24 cores and data lake technology, which we're using in our data distribution bus, streaming data to all calculational nodes. Now Mesos is running all these experiments. Right now we're looking at all 24 cores are used. We need to deploy 32 experiments. So at some point, one of the cores will become free. It will be used again, and we'll see that the amount of cores will go up and down depending on completion of the task. Of course, we don't have a full control of what Mesos does, but all we know is that you can see this amount of cores getting smaller, then get back, smaller and get back. It means by additional experiments, now we probably processed already 28 experiments, and we can always see when it goes down and back, means that Mesos will be in charge of deploying experiments. Cumulatively, we're expecting to process around 300 plus minus messages. What is a message in this particular context? The message is either closing day price or data from Wall Street Horizon and combined to the amount of experiments we run. And each experiment run 400 instruments over 11 years of data. So bingo, we've done it. So at this point, we run 32 experiments over 11 years of data. And this is performance report, but before we go to performance report, I'd like to explain the structure of experiments. So we're going back to the strategy home, and I would like to walk you through explanation of experiments. So this 32 experiments, and again, we keep all the statistics, how many messages we processed, what was average performance per message, is pretty cool. Each experiment, as we can see, have two factors, right? Day to hold position and days delta. So we see in this particular chart that every even experiment would be incrementing days delta, so we get 0 and 5, and every odd will increment the days to hold position. So we got cumulatively 32 experiments. Now I'll go back to my performance report and we'll see the inside. So what I'd like to do, I go quickly to scatterplot. And as expected, let me just remove all the unnecessary fields. I'll use the tools panel and I'll just uncheck all the buttons which have no relevance to what I'd like to show and tell you. Just keep only the things I need. So with that, let me just close this particular control. So as we expected, odd experiments have more trades than even ones. But what I really care about is Sharpe ratio. So we're going to see some very interesting, I hope we're going to be interesting picture. Bingo. We got two Brooks basically joined to one at the end. So let's see what we got. The experiment number 1, experiment number 3, experiment number 5. So we can clearly see that filtering signals based upon what we call the day delta or strength, is definitely not improving the strategy. And also what we see here, that as holding position longer is also not improving the strategy. So best performance is definitely experiment 1, which basically original was what we did, and we use Sharpe ratio here in percentages. I don't know why, but it's basically 1.63 Sharpe ratio, not bad for daily strategy. And with that, I would like to go back to Stuart, because this was just explanation of a Wall Street horizon strategy run on the cloud using QuantHub, doing 32 experiments.
Thanks, Ilya. So that was an alpha strategy research, or research on an alpha strategy. We're going to switch gears and use QuantHub now to do execution analysis. And this was a study that we did for somebody, it was very similar to a study we did for somebody who essentially had the problem, I have a bunch of traders, I have a bunch of positions that I need to rebalance, I get orders from my portfolio managers. Can you give me some heuristics on algo selection? When should I be using a VWAP? When should I be using a TWAP? Rather than just doing it from gut? Can you help me out do that more scientifically? So that's essentially that was the problem use case, if you will, that we had. And this is essentially what we came up with. So Ilya, if you could take us through this, please.
Absolutely. Thank you, Stuart. So I'm going back to QuantHub and go into this strategy called execution algo tester. And again, we have some predefined experiments, which I'd like to start from this one. So what we did, and you will see in this example, I also will explain how publishing in QuantHub works and how dynamic agents work. It's going to be pretty interesting result, but we'll start from me explaining the underlying idea. So I'm going to use charting for this purpose, and I will show you this particular chart, which will explain what we did for this use case. So we've got all equities, and we looked at historical data, and we built a strategy that just mechanically sends orders and executes them. So this particular strategy had 4 algos, and I'll explain in a second what they are. It's basically mean variance, VWAP, limit to market combi, mean impact, and it sends every 15 minutes the orders to buy between $50,000 and $100,000 of these equities. And basically, then these orders get filled. We calculate implementation shortfalls, and we show in these curves cumulative accumulated implementation shortfall. So the lower is the curve, the better is the at least implementation shortfall. However, standard deviation obviously is also very important, because some orders may be really not so good. So what are the algos? In this particular case, mean variance, it's just basically when we're taking the order and fill it using aggressive, either market order or limit order, but basically we want to fill it as soon as possible. VWAP, it's standard VWAP. We use 5% participation rate, and we also put the parameter where its order is not filled within 20 minutes, we convert it to market order. Limit to market order in the same combination of parameters. When order is not filled, we are, if limit order, we're putting it to some reasonably aggressive offset. If it's not filled, we convert to market order. And finally, mean impact, it's kind of pretty much TWAP. We broke all the 20 minutes or 30 minutes into 15 intervals. And again, at the end, if order is not filled, we convert to market order. So it's analogous to TWAP. In any case, what we see in this curve, that for Apache instrument, the limit to market combi seems like the best solution. However, if I take the different ticker, for example, National Oil Well Vargo, so if I go right now, type here NOV, and I click on this button, then the story is completely different. We see that limit to market combi is actually the worst one, which means that for each instrument, you're supposed to have different potential solution. So we build, therefore, the use case, we build the dashboard, which is currently this active dashboard shows us the diagram, which we basically use transaction cost analysis done kind of right, where we're choosing any amount of instruments. Let's say I'm just slide quickly, and we will look at 2 pieces of information. On the left, it shows us for 4 different algos, their implementation shortfall averages, and the right, basically it shows us the standard deviation of this execution algos. So if I zoom in this guy, we can see that limit to market combi has the lowest average implementation shortfall, however the highest dispersion, which is pretty bad. So we're going to use this type of widget, and I'll explain to you how we constructed it by going to, first of all, let me go and change this table because I'm going to publish this report. So let me just give it ILIA version 1.0 to publish. Let's say I'm typing here to publish. And as you can see, when I type it, it's immediately available, and this is active control. But I'd like to also show you one more thing about this particular technology. So this dashboard now is a part of my active repository. So if I go to this control and let's say tell it to edit, I can also edit this dashboard. It's all editable. And if I go to finish this edit, I can cancel it. This link allows me to include this report to the document. And finally, we've got additional reports. For example, let me just quickly add this report where I'm just showing some kind of waves, and let me save this report as visualization. I call it Viz. Click on OK button. So now we got additional visualization straight to our standard report. I get table, I got histogram, or I can click on Viz, and this will be available to anybody. So let me go back to this particular page, and let me publish these results. So I'm gonna tell this, I'm gonna share it with a different user. I got my own account, which I built as a, this is Ilya Gorelik as administrator. You can see my image here, in colors. And let me just publish it, add myself, and share it with me. We're gonna be logged into system as a user. So I click on Command OK. We get notification, and let me go to different box. You see, I got on a different computer notification that Ilya sent to me the strategy. So now I'm Ilya user, and you can see me in black and white. Bingo, I got this report, and I got all this publishing right available for me. And so what's left for me to do is to actually now do this and run this report one more time. So let me go back to my original computer. Let me just click on Command Run, call it Run Webinar, click on Command OK. We will just repeat this study where we're deploying these experiments on 12 cores. Since we're running on the cloud, we're going to see this beautiful thing, no matter how fast this particular computer is, how good is internet connection. Since I'm running on the cloud, I'm totally independent. So bingo, we did it actually pretty fast in 19 seconds. Click on Command Done. We're going to look at all the results. And if I click on this experiment, we're going to see that we run, if I go to this custom report, we run 78,000 execution algos. And here they are, 72,000. So I'd like to show you one more piece of very useful functionality, how I can do ad hoc analytics right here and look at transaction cost analysis, even though I'm a consumer of this data. So I received some study from somebody, I got it, I can look at scatter plot, I look at visualization. Now I'd like to group by symbol, and then I'd like to group by execution algo. So I got two levels of grouping, and for each subgroup, I would like to add statistics. First of all, average implementation shortfall, and we can see it right immediately. I click on Command Add, it will add it. And then I'll add one additional column, which I'm going to do standard deviation of implementation shortfall. I click another column. And now if I expand all my experiments, we see perfect. We can see for each instrument exactly the transaction cost analysis in the form which I presented. Or if I go back to my original computer, we will see the same thing in the form of a dashboard. So I guess that concludes my core material about QuantHub, and I would like to move to question and answer session.
Thanks, Ilya. We've had a number of questions come in, and a number of the questions are to do with data, and I'm going to amalgam them into 3 or 4 questions, which I myself will answer. I'll give Ilya a chance to get a glass of water, and then we'll come back. Ilya, I've got some questions for you. But getting to the data questions first, two of the questions have been, what do you mean by a message? And what we mean by a message is, think of it as a row in a table. It's a generic concept. So if you're looking at daily prices, you have one row, if you will, per day, per symbol. So that's, we call a message. If you're looking at best bid offer or level one data, you've got several best bid offer and trade messages per second. They are also messages. If you're looking at minute bars, you've got obviously however number of minutes are. So it's essentially normalizing what would otherwise be a very diverse array of granularity of data. So when we talk about messages, we may mean daily data, we may mean best bid offer messages, we may indeed mean level two messages. So we tend to use this phraseology message to generalize the processing of market data over some time period. That was a couple of questions. There's another question about, what's going on behind the scenes in terms of data. And so just to explain that a little bit more in relation to the Wall Street Horizon study, I talked a little bit about the earnings data that we got from Wall Street Horizons. I didn't mention, some questions came up about this. Of course, when you do any back test, you're measuring the performance, however you measure that, Sharp or anything else, with market data, whether that's close prices, whether that's last traded price, whether that's best bid offer, it's all market data. So in the background here, and specifically on master time base, if you can think of that diagram, we have a repository of market data, the futures data we got from Quant House, we've got other data from other vendors that is captured there that we use for the measurement of performance. And that's just normal, of course, in terms of any back testing. Other data sets, a question came in. So again, we've now talked about market data, we've talked about earnings data. Timebase can store pretty much any data. So other data sets that we have in there, Twitter sentiment, for example, news sentiment, fundamental data, of course, can go in there, and custom data. Some firms have their own custom, for example, ratings on companies or earnings on companies they'll put in. All of that can be stored in the data set. So I think that covers most of the questions on data. If they're not covered well enough, again, put in some more questions, but I'm going to move on now to another question. Ilya, there's one for you here. One of the questions came in and said, again, actually relating to the Wall Street Horizon study, you showed individual stocks, but can you show at a portfolio level how that strategy performed over time?
Sure. Basically, if I go to example where we show the portfolio behavior, as we know, we got all these different experiments. Since we know the experiment one is the best one, I click on this experiment, just get all the parameters. You can see the holding and those data highlighted. And I click on charting. And right there, we get to all the charts which we currently support. This is portfolio chart. By the way, we support the really cool feature where you can zoom in and refine your data. So it's concept of zoom lenses, where as data get more dense, if I zoom out, you can see visually it's going to be more sparse because your eye cannot see it. And we got the custom report, which is also kind of a QuantHub strategy where we look at portfolio, P&L performance, and hedging strategies and market volumes for hedging it for basically market values of a system. So that's kind of what you probably wanted to see.
Yeah, thank you. So there's a couple of other questions here which I'm going to merge into one, and this is to do with the actual simulation engine itself. So implicitly, when we backtest, we're simulating orders that hit the market, and how do we do that? So Ilya, there's a couple of questions here is basically, how do we calculate fill probability? What are our assumptions is probably a better way of rewording that. What are our assumptions around fill probability?
We have APIs which enable people to pretty much build any simulator. So currently, Deltix supports full range of simulation modes where we can fill based upon daily close bars, which is the most obviously coarse, to level 3, market by order kind of level data. So we got so many different simulators from order book data to level 3 data, top of the book data. And we also figured out that even though we provide all this, we still can't fill all the needs from everybody. So we're providing APIs. And if you, for example, working on level 3 data, you don't need any fill probability because then you can fill order based upon exact placing the order in the book. However, if you're working on the bar data and some kind of top of the book data and you need some assumptions, then you just can put APIs and calculate the fill prices based upon your own assumptions.
Thank you. There's a question here that pertains to the execution analysis we did that I'll answer. So somebody said, what was the measure you were using to determine the effectiveness of the algos? And you may not have heard it, but Ilya was talking about implementation shortfall. And implementation shortfall is one of the fairly standard industry measures for measuring the performance of execution. And it's very simple. It's literally the mid-price between the bid and the offer at the arrival of the order. It's as simple as that. So you just plot that and measure the executions against that. That's the arrival price. An alternative that we do, we didn't show it here, the other industry standard, of course, is VWAP, the volume weighted average price over the duration of the order. Ilya, another one for you here. We talked about the cloud and you've demonstrated more to the point using the cloud. Can you just talk about this in the context of public versus private cloud?
Yes, I can talk about it. So clearly, if we go to this diagram, it doesn't say what kind of cloud it assumes. The difference between private cloud and public cloud is obviously there's a lot of them. First of all, who can get access to it, what the permissions, what their roles, how do you protect your strategies, how do you build all this stuff. So dealing with public clouds, of course, is significantly more expensive, more difficult. Also, dealing with master time base and dealing with master market data. If you put it in the public cloud, who has rights to access it, who has no rights to access it. But in a big way, if it's all done and the world would be a perfect place, we put everything in the public cloud, right? We don't have to worry about securities. We don't have to worry about authentications. We don't have to worry about permissions and the vendor record, all kind of good stuff. Then, of course, it all can be done available in the public domain. So at this point, we're mostly definitely expecting that to be used in the private cloud, unfortunately, because of all the with building institutional system, right? And all the market data, all the authentication, all the security, it's going to be first release of the system definitely intended for private clouds. However, still clouds. And then it's going to be in the public, hopefully, when we gain the maturity. And that's how I see the evolution of the system.
Okay, thank you. So another question here that goes back to data, and essentially asking the question, are we holding all of the historical data in memory, which is a natural question. So Ilya, we obviously know the answer to that, but I'd like you to explain that because it's a good question and can talk about the scale of the data and just the impossibility of holding it in memory, I guess is the way.
Exactly. No, we don't hold not even remotely this data in memory. And that's why we put time base to every calculational node. We're talking about petabytes of data. So there's no way we can put it onto memory. Even experiments around today, the first one, 100 million messages. There's no cheap computer that can have all this in memory. So that's the whole architecture where we're using the Mesos and we're using data lake to stream data from master time base to remote time base. And because time base designed to basically stream data to CPU of a processor, it's incredibly fast. So in one core, we can run easy 1 million events per second. And so that's the assumption for scalability. So make long story short, we don't store it in memory.
So we're literally streaming it from disk. I mean, is the sort of corollary of that is it's reading it from disk very quickly is the way we get around, not get around that, that's the way you have to do it.
Mm-hmm.
Okay, good. So we've got one more question we're going to answer now, and then the rest that we'll get to via email. And Ilya, if you can answer this very quickly, just the collaboration side again, can you just summarize that? Don't show it, we haven't got time for that, but can you just summarize the collaboration aspects of QuantHub?
Sure. The intended aspect of collaboration is that there's two types of users who have publish rights and users who have only read-only access. So the quant should be able to publish the strategy, share it with the community, and then people who receive access to the strategies will be able to run them, modify them, and if they got rights to publish, they publish them back. So it will be like a blog, except it would be in a significantly more dynamic way. So that's how I see it.
All right. Thank you all for attending, and that concludes our webinar.